My name is Kelly Paffel, Technical Manager for Inveno Engineering LLC. This is the part 2 of steam quality. High steam quality is essential for the steam system, and today we want to talk about the testing methods, which is part 2 of this series. Steam quality. Let's talk about visual testing first. And visual testing is opening a valve to atmosphere. When we open a valve to atmosphere, a pressure drop will occur. So here's a high steam pressure. We're going to a low steam pressure or 0 psi. When we go through a pressure drop in steam system, superheat will be generated. Therefore, steam right here must be invisible. Must be invisible. So as I open this valve up, as you can see, it's invisible. So I have really good steam quality. Really good steam quality. Now it's not precise, but it gives me an indication of what the steam quality is. So going out and opening a valve to atmosphere will give us an indication of what steam quality is. Now, again, opening the valve, we go across steam quality, and we will get this. So the valve is in operation, opening, going through a pressure drop, and I'm looking at the discharge, and wow, that's pretty good steam quality. Pretty good steam quality. So, pressure drop across the valve will result in superheat. Steam will be invisible. Second. So I go to this valve here. So this here was causing issues in the plant, major problems in the plant because of the steam quality. In another segment, we'll be talking about what we can do to improve steam quality. Here's another application. As you can see in this this test for steam quality, you can see the amount of condensate that's coming from the discharge. And also you can see in the elbow the erosion that this can cause. So poor steam quality does erode steam lines and causes premature failures of steam lines, tracing lines, and other components. Even shown tube heat exchangers, the tube erosion can be caused by poor steam quality. Now, pretty good steam quality, as you can see here in this video here. You know, pretty invisible. It's pretty good steam quality. The true measurement of steam quality can be obtained by the use of a throttling calorimeter. Another way to measure steam quality is around basics of steam. Saturated steam is dry and visible, and becomes visible with entraining liquid, which we just discussed, which is opening a valve to atmosphere. True measurement of steam quality is a throttle calorimeter. So taking steam and coming through a pressure drop, and as I was talking before, when we go through a pressure drop, a degree of superheat will be produced. So by measuring that degree of superheat downstream, then we can tell the percentage of steam quality that we have. Very simple. These are just showing different older methods of calorimeters that were used to measure the moisture content in steam, and that's the word comes up, steam calorimeter. It does not measure the heat in steam, so it's not actually functioning measuring, reflects on the measuring device. Steam quality measuring devices use the same principle, which we describe in pressure reducing valves. So essentially this is a throttling calorimeter. This system here was developed by Swagelok Corporation, steam flowing through a steam line through the sampling system. So in this system here, you have a regulator. We know the pressure coming into the regulator here. Coming in, we know the pressure, and we can monitor the temperature going through a pressure drop and monitoring the pressure and temperature downstream. We can do our calculations and tell if we're at X temperature downstream or degree of superheat that we have 100% steam quality, or do through the calculation tell what degree of steam quality we have if it's not 100%. So this is a throttling steam calorimeter. Now, all plants have basically a pressure reducing station out there, and basically that's a throttling calorimeter. So anytime you're putting a pressure reducing station, you put a pressure indicator or a pressure transmitter. Doesn't matter which one, you know, you can use two of them. Downstream, accurate pressure indicator, temperature transmitter, and pressure transmitter. And you can use a temperature indicator also. But this here is a pressure reducing valve. We do this all the time. And when we put in pressure reducing stations is add in these devices so you basically have a true measurement of steam quality all the time just by going up and checking the readings, or sitting, if you're using transmitters, sitting it back into the distributed control system and having that tell you what your readout. So again, just to go through, you have a BTU content here, total BTU content, which is high, and going through to a lower pressure, your total BTU is going to be lower. So this difference in BTUs will produce superheat. So, and the technical paper has all the calculations for you, so please visit our website, which I'll show you here shortly, and you can get the calculations, or basically here. Just an example, inlet to the pressure reducing valve is 150 psi, total BTU is 1196. Outlets 15 psi, which is 249 degrees. The BTU is 1164. This is total BTU. So there's a BTU is 32 BTU difference. So where does this BTU difference go? It goes into superheat. The difference of BTUs is 32 BTUs. The effect of superheat, assume a specific heat of superheat to be 0.52. Each pound passing through will produce a superheat 32 divided by 0.52, or 61.5 degrees of superheat, if it is truly 100% steam quality. If it's not, condensate will be passing through the valve and then zapping the superheat or consuming the superheat, and will be below superheat of 61.5, or it could even be saturated conditions. So slightly it may arise from the values of specific superheat. For example, we used a superheat at 15 psi at 0.52, but it's very, very minor, very, very minor. So anyway, this is the best practice. This is up at our website. This will go through in much more detail than what I was explaining here in the video. And please visit our video, or our website. And here's our long-term and short-term path and my contact information. Please contact us if you have any questions. Have a great day.